Hello, everyone. Today is March 10th, 2021. This is the Kubernetes Data Protection Working Group meeting. So today, we have a few things on the agenda. So we're going to look at this issue with a different volume mode between source and target PVCs. Just to look at what are the issues and what we should do to solve the problem. And then we can do an update of the data protection white paper. Okay, so the first one is this. So we actually have an issue open here. So actually what happens is right now we actually can do this. A user can create a PVC with file system mode, take a snapshot, and then create a new PVC with block mode using the snapshot, or vice versa. So you basically can actually switch the volume mode between the original PVC and the final target PVC, and then this is actually used by a lot of backup vendors already, because this allows them to mount a originally file system mode PVC as a block mode, and then they can efficiently copy the blocks. But then we actually discovered there is some potential security issues. I see Yang here. Yang is the one who actually discovered this potential problem. Do you want to describe what that is?
Okay, I can. First thing, disclaimer, there is no security issue right now. Everybody is safe. The only thing is that from time to time, there is a security issue in kernel, in ext4 or XFS file system. So if you mount a volume from untrusted source, you can crash the kernel or do similar bad things.
By like writing malicious file system in raw block mode?
Yeah, exactly. So people usually don't mount files like random block volumes, and people who can mount are usually somehow trustworthy. But in Kubernetes case, like a random user can mount a random volume. Luckily, in Kubernetes, we do not allow to change the mode of the volume. So if you start with a file system volume, you have a file system volume, you cannot access the device and do bad things there. Similarly, if you have a block volume, you either have a block volume and you can write anything there, but you can't mount it, or you are trustworthy enough to mount it, and then, well, you have extra permission, somebody allowed you to mount it. But in this case, in this snapshot case, you can create a block volume, write a wrong metadata there, the bad file system that would crash a kernel, and then tell Kubernetes to mount it by taking a snapshot and restoring it as a file system volume. This way, a very ordinary user can crash the kernel once such CVE is found in kernel. Was that understandable?
Yeah, that's actually, that sounds like we do have an issue right now.
Well, we contacted security team, Kubernetes security team. These issues are usually treated as medium severity in kernel. And having this possibility through Kubernetes doesn't add much. Somebody did the counting and it ended up as medium as well. So these issues are usually like fixed, backported in the kernels, but we should know they exist, and if we can, we should also prevent them.
You mean like have a knob that allows an admin to decide whether this behavior is okay or not, or to limit the set of users that can convert back and forth from block to file to a subset of all the users? Is that what you're suggesting? Yeah, That makes sense
well,
to me, given if we believe the only use case for doing this is like a backup style use case, and you could just have one role that is able to do it, you could limit everyone from being able to do this except for the backup user.
yeah, if it was that easy.
Why?
Yeah,
No, yeah, I'm saying like that would be a new feature we'd have to implement.
right.
I just wanted to add some extra background for other people here. So while Kubernetes allows you to do this, you know, take a snapshot of a raw block volume and turn it into a file system volume and vice versa, not all drivers succeed when you try to do this. So it's up to the driver whether this actually works. And some drivers allow it and some drivers don't allow it. In case that wasn't clear. Like Kubernetes allows it, but it doesn't require drivers to succeed when you try it.
Ben, when you say allow it, what's the criteria? Can you give an example? Because I was asking exactly the same question, right? You
Yeah.
need
So I'll give a perfect example with NetApp. So NetApp, our driver supports a few different modes. We have an iSCSI mode and we have an NFS mode. If you are in the iSCSI mode, there is no reason why you couldn't do this. You know, create a volume in block mode, then turn it into file system mode, or create a volume in file system mode and turn it into block mode. We could implement that. We actually don't implement it today for, you know, because we didn't realize this was a thing that people were even interested in. So if you try it today, it will just fail. But we could implement it for iSCSI. When it comes to NFS, like when you ask for a file system, we give you like an NFS share on our storage controller. We have no way of exposing that as a raw block device because the raw block device is inside the storage controller with a proprietary file system that isn't directly accessible outside the storage device. So like,
But your
if
driver
you're
will
using
fail, right? In that case, when you
Hmm?
create if you want to create a PVC, you set exchange mode. In this case, your driver will fail.
Yeah,
right?
yeah. So what
Create
I'm
time,
saying
actually, at create time.
is you're welcome to try it, but like it will just fail in crate volume. You know,
Right.
when it'll say you can't create block file systems on our NFS driver. It's like, well,
So
yeah.
so that will fail even if it's like a empty, because that's basically it's not supported anyway. But for some,
Well, there are ways to do raw blocks on top of NFS by like creating a very large file and turning it into a loopback device. Like people play that game,
that
right?
right.
And
That's
so
true.
like
Okay.
we don't do that, but like one could imagine an implementation that did. And
So
in that case, you also would not be able to swap back and forth between blocks and file system.
right, but so I was just wondering if that would fail in all. I mean, would all driver fail actually, or will any driver actually kind of create something which has the wrong mode, but they actually do not support, and then later on find out the data is corrupted? Would that even happen? I'm not sure if that's a possibility.
That seems like a place where maybe more test coverage would help uncover issues. I don't think none of the drivers I know about have that problem. Like if you ask for us for a driver mode that isn't going to work, there are regular error checking will tell you that,
Okay.
and we don't proceed. Because yeah, the issue exists with empty volumes too. If you ask our NFS driver for an empty raw block volume, we'll say, sorry, we don't do that. Use iSCSI.
Just to be clear, right? The potential security concerns in the issue 477 Xing created is just taking a snapshot of a block device and then restore into a file system, right? It's not the other way around. If you take a snapshot of a file system and restore into a block device, since there's no attach, can we claim that that's a safe operation per se?
I think so.
That does feel safe, but there's a lot of nuances around this whole capability of doing conversion, because, and this is what I wanted to get into, aside from the security issue, is just the whole concept of CSI and FS types gets extraordinarily complicated when you have volumes that can be either a file system volume or a raw block volume, because you can do there's a CSI call called like get volume capabilities, where you can ask an existing volume, do you support this file type? And Kubernetes doesn't currently use it, but it's part of the CSI spec. And it's unclear what you're supposed to do if you have a volume which like used to be an ext4 volume, but it got snapshotted and then turned into a raw block volume. And then if somebody comes and asks like, do you support ext4? Like, it's hard to know how to answer that question, because it's like, well, it's a raw block volume. So no, you can't mount me as ext4, but if you take a snapshot of me and turn me back into a file system volume, it's gonna be an ext4 volume, not like an XFS volume or some other file system. So it's like, you could argue for it should remember the file system it used to have before it got turned into a raw block volume. And you could also argue that it's ridiculous to remember that. And I don't know what makes more sense. But there's this expectation of the CSI layer that drivers know what file system is on the device or on the volume. And when you're converting back and forth from raw to, I mean, you could imagine creating an ext4 file system, taking a snapshot, turning into a raw block device, wiping all of the data on the volume while it's a raw block device, and like putting an XFS file system on that, then taking a snapshot of that and then creating a new file system volume and then expecting it to work. And I don't know how the CSI plugin would have any idea that it has an XFS file system on it, as opposed to an ext4 file system, because it was created by a user. So we don't even have a way for people to tell the CSI plugin like what they're doing.
I agree. I totally agree with that. But should we be aware of that? It's still a question, because the volume is now in the user's hand, right? They have full access to the volume. They can do pretty much whatever they want in the application layer, as long as they are given the corresponding privileges.
Yeah. Well, and in this case, that there is no privilege. It's just, you know, if you support raw block volumes, all users get access to that.
Hello, Jan. I have a question related to the security issue. You say that if some rogue, the software can mount the block device, and it would potentially corrupt the kernel. You are talking about the kernel of the Linux on the pod kernel, or on actually on the Kubernetes API server or node? Which one?
The whole node.
The kernel on the node, yeah.
Can be compromised.
It could potentially crash the node, right? So one of the issue that you brought up, Jan.
Mm-hmm. Usually it crashes. Sometimes it does something more.
It would depend on the vulnerability. You could imagine a vulnerability that allowed you to gain control with a carefully crafted data in the file system.
There are usually few per year.
Okay, so
we are preventing that happen by doing what? By not allowing to mount the block at all, or what?
No. So we are talking about
preventing this.
if you look at this one, right? So we know that that's an important use case for backup vendors. So we're saying we want to be able to support that for backups vendors, but not allow that to be how to say, exploited by the malicious user. So basically, we will need to introduce some admissions control type of thing. So
let's still be clear, right? Jan said this.
It's not clear. It's just this is something that we're thinking of, how to prevent this, but then still supporting this for like backup software that
like do you have like a pod security policy switch or something that would control this?
I don't know. So I was actually trying to. This is really just something I come up really quickly. It's not really thought thoroughly yet. So I think there are a lot of details we still need to figure out, right? So this is just some possible solution. So we need to have some kind of fallback rule that allows this, and then only like a backup software is a user can be allowed to do this conversion. If we are trying to create, if we're trying to create volume from a snapshot with a different mode. But then that also means, because right now in our volume snapshot, we don't really know what is the existing volume mode, right? So that also means that we will need to add an alpha field in the volume snapshot. So this is like when we are taking a snapshot from a PVC. So we know what is the mode on that PVC. So we have that recorded. So that, and then in the CSI spec, we can add a new capability. This is the second point that Ben was talking about. So the CSI driver will need to say whether it supports this or not. If it's supported, then we will allow this mode conversion. So I think this part, I think still need to think about.
Hold on,
so,
just to quibble with your suggestion for the CSI spec, this would be a backwards incompatible change, because this works today, and by introducing a new capability, it would stop working.
Okay, then we'll just do the other way. So it's so we will say by default this is we allow conversion, and then
and you can declare.
So we'll say block or something like that. I don't know. We'll need to call it the other way. So okay,
yeah, an inverted capability.
Need to support convert by default, right? Or backup or backward.
Also, for existing volume snapshot resources in current Kubernetes system, this volume model is not there. That needs to be backward.
Yeah, that's like an extra field that will be alpha, right? So like this will be like a new alpha field just for that one.
Sure, but why did you put there for existing ones?
Existing ones will not have that. So this will be only for new. This is only
existing
new
ones
ones
would be blank, which means
so it's going to be an option. So it's like a pointer, right? So
but
if
that's
you add
what I'm saying. Then for in order for existing ones to keep the original behavior, or should we keep the original behavior?
So so if the original behavior is already there, then we need to keep those, right? Because that's already supported. Yeah. So this is only for, I think we can, I don't think that we can actually block the old ones. That will be backward incompatible, right?
Yes.
So yeah, so by default, this is just a null by default, right?
Because snapshots are a GA feature.
Yeah.
They have to continue to work exactly as they work.
Right. So by default, this is no, and then if this is set, then we will based on how that is set and decide what to do. Right. For existing ones, then we don't handle those existing ones. This is a new feature. So new optional feature.
So I want to propose a slightly different flavor, and I haven't thought deeply about this, but like, if you have a volume that's like, say it's an iSCSI volume, the volume itself doesn't care whether you try to attach to it as a file system or a block device, right? Like you can do that on a pod by pod basis. You can say, okay, this guy wants to mount it as a file system. This guy wants to mount it as a block device. The fact that Kubernetes has a PVC with exactly one value is kind of limiting. If the underlying device doesn't care, then it would be nice if Kubernetes knew that, and it could just say, okay, for this PVC, you can mount it however, and you wouldn't have to bother going through the rigmarole of snapshotting it and creating a new volume. Because the actual state on the system is either you can mount it either way or you can't. I would be very surprised to know of one where like you could mount it only after a conversion, but like not as it is right now.
So you are basically proposing to even open this up even more, basically, because currently we do not allow a PVC to be cloned if the mode is mismatched, right?
That's right, and that doesn't make any. Doesn't make any sense, right?
So you are actually saying that let's open this up even more. Right now we're trying to.
What I'm saying is the volume clone behavior should match the snapshot clone behavior, and if we put any controls around snapshots to prevent things we don't like, then the same should apply to volumes, but the volumes should be no more limited than snapshots, right? Because all a volume clone is a shorthand for take a snapshot and then clone the snapshot and then delete the snapshot.
I think But I think for backup cases, snapshot is important. I don't think they always want
I know,
to
I'm not,
do the
we
clone.
definitely need to continue supporting snapshots, but I'm saying there's no reason to limit direct cloning of volumes, given that it's reducible down to a snapshot and a clone. So we don't achieve,
So
anything
Jan,
by
do you have any
blocking it.
comments on this?
Like in the
Can I
long
ask a high-level
run,
question? Sorry. So I think we started this discussion back when we were talking about the change block tracking API, right? Design, which
Yeah.
only considered block volumes, right? And then somebody asked, how does this work with file system volumes? And then we went down the path of, can we even, create a
That's for the there is a change file list, right? That's the different. So we're saying that that is like a different design. It's not, we can't combine them. It's just so different. We can't possibly combine them. It's not like
Okay,
we don't support it.
So that was for block storage, right? Not necessarily block volume.
Yeah.
So that will support block storage, irrespective of whether the PV mode is file system
Right.
or block.
Yeah.
And today there are CSI plugins that let you convert a file system volume to a block volume, and then do presumably the change block tracking could be done. And then when you want to do a restore, you can convert the raw block volume back to a file system volume.
No,
And
basically, I'm trying to find out whether there's a legit use case for this conversion. And if there is no legitimate,
this conversion is, the conversion that we're talking about, if it's a conversion between the block mode and the file system mode, you're saying if this one is needed?
no, I'm asking, is it needed? Like, why
It
is
is
it
needed.
legitimate?
This is needed by backup vendors, right? So maybe let's see who want to explain this. Backup vendors here.
I think there's actually a number of use cases. But classically, like if we take a look at Unix, we'll have like the raw device is not something that's accessible to everybody. And I think that's kind of what we're running into here, right? Is that the basic bug is the user converted a volume to a block volume, twiddled with it, and then was able to crash the system, right?
Yeah.
And we're trying to say, is there a legitimate use case for being able to twiddle with the blocks? I think there is, but I think it's also reasonable to say that's something that we could restrict most users from doing. Because we've got scenarios like backup is one, data recovery. I've worked with data recovery tools that go through and read around the file system and reconstruct file systems beyond what FSCK does. We could see that as a use case in Kubernetes. You've got 1,000 volumes that are trash. Well, spin up a job and run the data recovery software and all of that. We probably won't be doing that for 5 years, but I think we may wind up there. So I think the use case of getting the raw blocks is real, but I think we could restrict when you can do it or who can do
The way I look at raw block, I think it's like an opaque, blob of bytes, which.
Well, that's because you're not a file system guy.
I'm actually a file system guy.
I mean, but seriously, I mean, FSDK, block-based backup, data recovery tools. These do not. These understand the internal structure. Databases. These will understand the internal structure of the file system.
And I think the onus is on the application to take care of how they want to back up that raw block. It's not on the CSI plugins or Kubernetes. I think the application should take care of raw blocks backups.
Well, no, this is typically what we've been doing, like from the vSphere side, right? We typically do backups at the block level. We take a crash consistent snapshot, and then we slurp out the blocks, and that's the fastest path.
So in this case, yeah, VMware will be the application because VMware understands how these raw blocks are formatted and used. And
no, from our point of view, it's a blob, right? We provide a virtual disk to Kubernetes and attach it to a VM. So from our point of view as a storage system, it's a blob. We don't care what's in it. We don't look inside of it. The backup application comes by and looks in from the block level.
Yeah.
So,
I'm
so,
not
so,
sure.
so Ardalan, there's multiple ways to implement backup at the application layer, at this layer, or down at the storage system layer, and they're all legitimate in different situations. I think the problem we're facing is this feature is GA and this works now for CSI plugins that allow it. So we have to do something about that.
Now I'm just separating the security problem from the use case, like that we're trying to support for the backup. So like I'm just separating the two. And
Right. For one flavor of backup, this is essential. It sounds like.
And then that's what I'm questioning. Is it really essential or not? That's my question, basically.
I mean, I personally don't care about this flavor of backup, but I don't deny that it's right to exist.
Yeah, I mean, so that is the flavor, right, where that's enabling CBT, and also unless we block backup at block level, and then have this capability to get these change blocks, then it will be a limiting factor if you can't do that at block level.
Okay, I guess. Is there a document that would outline why this is a?
Was it? I wanted Xing to finish her proposal. I wanted to see how far this goes towards solving it.
Oh, this is actually okay.
Well, I think this proposal basically is based on the premise that this convergence is needed and essential,
Right.
and how
So
we
that's
can
actually,
protect against it, right? And I'm just
so Fang actually did a presentation the other day, right? Talked about the CBT, right?
Yeah.
Yeah. So there are backup vendors definitely rely on this to build their software.
And after that presentation, I went off and I wrote a POC CSI driver that supports this, and that's when I discovered how hard it is to get the file system type metadata correct when you're going through these conversions back and forth, and you don't know what the hell's happening when someone's accessing the raw block version of the volume. And that was my big concern, was the CSI spec is too vague about what you're supposed to do with FS types in this situation. And there is a way to do it right, but it requires making a lot of assumptions. So I like, I mean, given that this is allowed today and it's GA, we can't just yank it back and say, nope, you can't do it anymore. But we can, I think, find a way to control it better and put access control around it so that it's not abused, and that if it's not going to work, for like an NFS-based driver where this is never going to work, we can just say that and then have better error handling.
Okay. All right. So let me continue. Actually, I was actually halfway through. I think I talked about adding some capability in the CSS spec, and then I think this is actually the difficult part. So how do we add this RBAC rule to prevent this? So I'm thinking that we need a validation hook, and just to check this rule. If if we detect that okay, this mode does not match. This is of course assuming this is in the status, but that's still we need to debate and see. I don't know if that's the right place for that. But if there's a mismatch, then the validation hook will check if the RBAC rule is set. If it's not set, then that's just not allowed, right? And then in the external provision, we already have some code today that checks for the clone. If at the clone time, if there's a mismatch, it actually will block it. So we could make some.
Hold on, Xing.
Yeah.
Validation webhooks don't know who is making the call, right? They have no identity.
Yeah, so I think so basically then you just have to set the rule. The rule will only be assigned to the user who are allowed. So that's the thing. It's not like we so basically we know those are trusted users. So we only assign those people.
But the point of enforcement has to be a place where you have a context that you know which user is trying to execute the action. And validation controllers have no context of who is trying to make the change. They just do the validation of the change.
There's a creator field, but that's not reliable in general.
Okay, so you guys have, yeah, this is as I said, this is I'm not really sure about this party. This is actually the hard part, like how to prevent, right?
Another thing, right? The
Mhm.
while model cannot be in status, right? How do you do importing if it's in status?
Well, so we can't have that in spec either. That's a problem, right? Because that's actually when we take a snapshot, right? So PVC is already, we already know the PVC, that's the source. We're not supposed to also get because the volume mode is not requested by the user, it's already
Sure,
part of
my-
actually PVC.
Hold on, you can put it in the spec and have a validation rule that it can only be updated from empty to having a value, so it can never be changed after it's set, and then have a controller that sets it properly. And
No,
if the
but
user,
it doesn't make, no, I'm saying it doesn't make sense for a volume mode to be in volume snapshot. Because the volume snapshot, you can't really request anything. You take a snapshot,
no,
it's going to be the
I'm
same
saying
as
that
PVC.
I'm saying the user would leave it empty and a controller would fill it in with the
We
value.
could, I mean, this is, I'm
Like-
not saying this, normally if
like-
you get something that is already there, then since status, that's why I put it here.
But putting in the status will, just will not make the static binding thing working, right? The static provisioning is not gonna work. You don't have the reference
Why the
PV.
static provisioning will not work? You're saying so because in the static provisioning case, we don't have this one to start with.
Yeah, there's no snapshot, there's no source PVC. It's all
Mhm.
handle.
Yeah, that's also true. Yeah, if you're just importing a snapshot that exists, you have to be told by the guy importing it what is in there.
It has to be a field in the content.
Yeah, so that's another another way, right? So we can put that in the content. Yeah, this is just something that I just showed up this morning. Didn't really think through.
Yeah,
we need it somewhere in the snapshot somewhere so that we can compare it. Okay.
But I think it's going to be important to think through the backwards compatibility case. So people are going to have a huge number of legacy snapshots that have this value unset, and for those snapshots we have to preserve the old behavior. What we would like to do is maybe provide a recipe to an admin who's worried about the security threat. Say, hey, Mr. Admin, you can go through and update all your snapshots with the correct value if you know what it is, and thereby protect yourself from the security threat. And then maybe that would be sort of a path to get a legacy system updated to be secure.
correct. We need to think through all these cases, as Ben was saying, and luckily we currently do not have any issue at this moment, and non-issue at this moment. So we brought this up. We still have time to fix this slowly in the right way.
Yeah, I just want to start this discussion, and this is like brainstorming. This is no way. I just read this right before the meeting so that we can get something to start. We can start discussion. Yeah, so this part, I'm not sure. This is actually kind of tricky. I think this how to how to block this. Yang, do you have any thoughts on this? Like, if we're setting RBAC rule, I know the security people are actually suggesting something like that, but you can only have this rule apply to a resource or a sub-resource, right? So I'm actually not even sure. So that's why I was actually thinking about the new CRD or something.
Well, it feels like the equivalent of a pod security policy that's like a volume security policy is what's needed, because it's
volume security. Okay.
It's not really tied to an individual user. It's just tied to the resource. So that all the security policy switches for pods exist on the pod security policy object, which applies to all users. And then I think there might be some mapping of how users that can request different policies, but you kind of need something like that where the policy object exists independent of who's trying to do it. Because again, if you just have objects in the Kubernetes API server, you don't know who made them. They're just there, and you have to react to them as a controller. And so, yeah, in none of the places where we want to enforce it do we know who is trying to make the action, right? It's always, we just see objects and controllers react to objects.
From what I got from the discussion with security guys is that there is a object called subject access review where anybody can ask API server if particular user can do particular action. And we were suggested to use that to check if this guy can restore volume as block.
Yeah, I think when I was reading that, one thing I'm still not quite sure is they talked about this. I think they talked about persistent volume claims review raw. You know, that thing. Is that like a field of the PVC? I'm not quite understanding what that means, because looking at the RBAC rules, because they talked about RBAC rules, I think those are all.
You need a user, right? But it's basically the fundamental problem Ben was presenting is that who is creating this PVC?
Well, I didn't check much, but from what I saw in documentation of webhooks, they pass user info with username and groups and whatever. So are you telling me that this information is wrong?
Which information is wrong? I'm sorry, I'm not
sure. In webhook, in admission controller, you get JSON. Is it JSON? Some object with, how is it called? Admission review, and the webhook sends a response. Right. And this admission review
I thought that's what they
username.
say. I thought that's what they say, that use the check the row.
That's what CJ said, right? But in this document, what it said is the PVC, which is not the correct thing, right? If we go up a little bit, please.
I didn't say PVC. I was talking here. Here is what I was. I'm not. So this is the part I'm not quite sure. Like how does this actually look like?
You don't need the CRD for that.
Okay, so this is the part that I'm not quite sure, because when you're setting up the roles, right, you would need to, it's kind of, just look at this as an example. Doesn't matter what, this can be something else, but this can be PVCs. But I think the problem I'm having is we're not talking about the whole PVC resource. We're not talking, are they talking about this one field of, I'm not sure what they mean by this.
No, this is a permission.
This is a permission.
This is a permission, right? Okay. This is a permission attached to this persistent volume claims.
Okay.
Xing, why don't we take all this RBAC rules stuff offline, because we have another item in the agenda. We can discuss a little bit more on that and come back with the full picture of this whole RBAC rule.
I think so. That's a good idea. Yeah.
Okay. We could do that. All right. Okay. So so we have talked about the first item. I just I was want to start this discussion, and the second item is white paper update. Tom, do you have an update on this?
So I still have to schedule a meeting to get feedback on the motivation, so people can ping me unless we've already chatted for being added to that. I haven't made progress on the cleanup for the application examples, so I'll try to do that by the meeting. Maybe we can do Friday or something to go through that. But we can definitely review the motivation section here asynchronously and before that meeting if we want.
Okay. You want to go over this? Or you want to get feedback offline? I'm sorry, I didn't get what do you.
I think this is not the right place to go through it.
Okay, sure.
Feel free to read and get feedback, make edits, whatever would work best.
Okay. Yeah. Okay, we can do that.
Cool.
So do we have a? Yeah, I think that's probably the main update. Does anyone else have an update on the white paper? I think I forgot to assign this to some people, so I need to actually go over that and see. Okay.
Xing, I know that you assigned me a section of the white paper about populators that I never did fill in.
Oh
so
yes, please.
I
No,
still have a to-do for that. I'm sorry that it hasn't
Oh,
happened.
okay. Yeah. So if yeah, I know you're busy with other things. So yeah, if you can add
Well, yeah,
fill that section, that'll be great.
I can report to the group here that we didn't manage to hit the code freeze deadline for 121 with data populators, so it's going to slip to 122. But the work continues. It's going to be one more release before we hit beta.
Right.
Yeah.
I think for the white paper related to the data protection for the application backup and restore, I think we have some rough draft of it. But we need to sit down and rewrite it, because right now it's in like in a very chaos format. So maybe we should have a next meeting, or we to discuss about who can do what to clean it up, to make it into like a white paper format. And from last time we talked about the application backup and restore, there is a lot of feedback related to one scenario is restore to original PVC. And I think that seemed to be a little bit too specific to, as to EMC. So maybe we should remove that segment from the main white paper and move the.
I'm sorry, Fang, what section you're talking about?
Oh, that was when I present that scenario. It was related to restore to original PVC, where you do not create the new PVC, but you restore to the existing one.
Yeah.
And that seemed to be too specific. So maybe we should remove that segment out of the main white paper, but put it into like an appendix or something, so that for most people would only concern about backup and restore application to a new PVC, then that would be like generic for everyone. And the one whoever interested in the restore to original PVC, we can put it in like an appendix section or in the white paper. Yeah.
Okay.
Yeah.
Okay, sure. Anyone else? Okay. Okay, so I think that's all on the agenda today. Does anyone have anything else you want to talk about? If not,
where are we going to handle that offline discussion about the
which? Yeah. Okay, so I will set up something. We need we'll need to talk about this. Yeah.
Okay.
Yeah, please loop me into that discussion on the security solution. Say, yeah, whether we want to mount, convert a file system, a PVC to a block system PVC is important to me. I mean, at least, yeah.
Okay. Yeah. I think it's just we definitely want to, we want the backup vendor just to be able to support that. Yeah, just need to figure out how to control this better. Yeah.
If there was a specific proposal, like where we had a POC that kind of sort of worked, that would make it easier to have that discussion.
Yeah, no, this is right now just I'm just starting the discussion. So I just want people to know. I know that you wanted to talk about this. That was actually before.
Yeah, I'm very
security thing, and now this is a new thing just came up. Yeah,
I'm glad you brought it up, and it's a good introduction to the subject for a lot of people. And yeah, I just don't know how you're going to express who is allowed to do this and who isn't allowed to do this. That seems to be the hard part. And then
where
you're going to enforce that.
Easy. Yeah.
But I hope it's solvable.
Yeah.
Hey, Ben, was your example what you're talking about? I mean, you said you built kind of a POC for this.
Well, I just built it, given that the regular NetApp CSI driver doesn't let you do this. I built one that does, just to see what would be involved. And I encountered all kinds of problems that had nothing to do with the security issue, just like the basic.
Yeah, just allow conversion, basically, right?
Keeping track of what the file system is, so that when you go through a file system to raw block to back to file system conversion, you have a sense of what commands you're supposed to be running on that volume. Because if somebody swapped out XFF for EXT while it was in raw block mode, then all bets are off. You're going to have problems.
Yeah, definitely.
Is this on NetApp storage, or are you using your some test storage to do this? Shouldn't this already be handled by the storage system?
No, like iSCSI storage, it's like the VMware case where we provide you a bag of bits and we never look inside. The only thing that knows what's inside is the CSI plugin. And the CSI plugin only knows what Kubernetes tells it or what it stores by itself, and so it has to play a lot of games to sort of keep track of what's going on with this particular iSCSI LUN. It was surprisingly hard. Like I thought I would sit down and do this in an afternoon, and it took like 2 or 3 days to get it to work.
Yeah, so I'm not. I thought this just like a lot of driver could just support this without anything additional.
You can, but like doing it safely is not so easy, because there's all sorts of situations where the plugin is expected to know what the file system is. Like if you need to do a resize, like do you run resize E2FS or do you run XFS GrowFS? Like that requires the plugin to know. And if
you are actually thinking about you want to change the mode, you will still be able to write to it. That's what you are trying to do.
Well, yeah, the problem is when you're converting back and forth, like you lose control of what's really in there, and so you need to have various safety checks that at mount time say, does it match what I think it is, and if not, what am I going to do about that?
Okay,
yeah.
So
that's why I want to talk about the broader use case of
whether these the use case is actually not really changing back and forth. The use case is just change one direction, right? I mean, yeah, if you want to always do that, then I mean that may be tricky. That's why I was a little surprised you're saying that you have to write that.
To be clear, the backup use case involves converting one direction for the backup and converting the other direction for doing a restore. Like you do need both to do backup and restore.
So you don't have to go. Yeah. So I'm just saying that use case, it's straightforward. I don't believe we actually need to make any additional changes. That's my understanding.
But the basic problem is when you're doing, imagine you have a backup of a file system volume stored as a bunch of incremental backups of a block device, right? Which is how I imagine this happens underneath. When it's time to do a restore, the way you would do the restore is you would create a raw block device, you would restore the base and then apply all the incrementals to it, or you would do that all at once. But somehow you would start with a raw block volume, you'd schlep all the stack of incrementals onto it to get it to the state it needs to be in. Then you take a snapshot of that and turn it into a file system volume and hand that to the user and say, here's your restored volume. The problem is, like, at no point did you get to tell Kubernetes what file system you thought was on there.
We've been doing that for a while, and from the backup application level, right? Like Valero keeps track of the PVC and the PV and does a static provisioning, and I'm pretty sure it slams in whatever file system it's supposed to be.
Yes,
so it doesn't expect the CSI driver to know it.
But the problem is if what the CSI driver thinks it is doesn't match what the application thinks it is, you can run into trouble.
You're going to run into trouble no matter what, because it's pretty easy to put the wrong file system type in, right?
Right. And so as a CSI plugin author, like I have to worry about that. I have to handle all the errors that occur when it's wrong.
But that can occur anytime. I mean, the user can simply try mounting a volume. They could delete a PV and then recreate it, right? So you've got the same problem. It's not backup specific.
I'm just saying, like, for doing things like resizing a volume, you have to know what's in there, or you have to at least have an idea of what you think is in there, because there is no generic file system
resize. That's a different use case now, right? Talking about the resize.
Yeah, by the time you get to resize, you're going to have converted it back to being a file volume, right? A file system.
Maybe.
So
Maybe,
in the
maybe
backup
not.
in the backup
Well, I don't
restore
think
case,
it
you actually
makes
should.
any sense to
Well,
do a resize on a raw volume.
But you
well,
can.
so in the backup
Probably
restore
fail.
case, actually, you should already you need to back up your metadata in your PVC anyway. So everything in your PVC YAML should be stored. So you actually know what you have to restore back with, right? So that's something that you should not have to guess.
Right. The problem is there's no way for the application that knows to tell the CSI plugin that wants to know. There's no communication channel there. So regardless of how smart the backup application is, you can't inform the CSI plugin that like, hey, this raw block volume that I'm creating, I'm sticking an ext4 file system in it just for your information. Like the CSI plugin has to figure that out empirically, and it's a little gross. That was my big complaint.
It seems to work end to end, but you're just pointing out the kind of robustness issue, right, Ben?
Yeah. It absolutely can work if you don't do anything hokey, but the problem is no one's preventing you from doing anything hokey. And so if you're defensively programming your CSI plugin, you have to think like someone who's trying to fuzz your API and doing all of the bad things.
Because it's you really just you change it when you change mode, it's really read only at that time. You're not really, I mean, I'm talking about the backup case, right? So you're not really making any changes. So actually I'm not
it's the restore
getting
case.
what changes you have to make in the CSI driver set. That's what my question is, because I'm not aware that we have to do anything in the CSI driver to handle this. So maybe other driver do. So that maybe that's the part that I didn't get.
Yeah, it's at restore time, you have to write to the raw block volume and then convert it to a file system volume. And if nobody lies to you about what the file system is, you're okay. But if someone lies to you about the file system, you will get weird errors.
Yeah, but that is that's the responsibility of the upper level, the backup software, right? It needs to know. It needs to know what that is. Because otherwise, I mean, there is no way for a snapshot to have all the metadata that is stored in the original PVC anyway. So even if right now, I know we're talking about we need to save this volume mode, but there are still tons of other information in the PVC that if you don't save it ahead of time, then when you create a volume back, it's not going
the
to be
CSI plugin,
the same.
The CSI plugin has metadata, and it
CSI
can.
plugin is not going to if you don't have the all the metadata, and you don't really know how to create your PVC YAML when you're creating a new PVC from the source, right? If you don't have all those parameters, that's like user side. It's not like you are going to read from the CSI drivers to get that. That's not the case. So there's
the thing that gives me fits is that there are capabilities checks in the CSI driver that are supposed to fail if the capabilities that are requested don't match the actual capabilities. And you're allowed to, when you create a volume, say like, I expect this to be XFS. And if it's not, you're supposed to fail. And what you're saying is like, well, you just have to trust the application that says, yeah, it's XFS, trust me.
Right.
Well,
so
hold
application
on. But you can identify, you can fingerprint the file system as you try to mount it or before you mount it to say, is this an XFS volume?
Right, but the create volume is not in the data plane; it's in the control plane. So create volume has to go only on the metadata that it has. It can't actually read the bits and see what it's dealing with, because create volume is running in a controller somewhere.
Well, at some point you actually have to initialize like an XFS file system.
Right. Like the node does that, and so that's why I'm saying like the node has to know. It needs to know to do its job, and then it needs to store. There needs to be metadata tracking somewhere what the system thinks, what the CSI plugin thinks it is, and then to implement all the capabilities checks that CSI says you're supposed to implement, you have to store that metadata in a place where the controller plugin can always access it for both snapshots and volumes. Otherwise you can't implement those capabilities checks correctly, and you have to lie. And as long as no one's doing anything weird, those lies never get caught. But the moment someone does something strange, you could end up in a bad situation.
Well, I think it would be worthwhile to separate out like dumb things users do that cause them headaches that we would like to make better, and
Yeah.
dumb things users do or malicious things users do that actually cause security holes, like crashing the worker nodes or elevating privileges or things like that.
Yeah.
Okay, time check.
Okay.
Yeah, we're at the top of the hour. Yeah, so yeah, well, we will need to think about this more and come up with a solution, and we'll discuss about this again. All right then, I think that's it for today. Thanks everyone.
Thank you, Xing.
Bye.
Thank you.